Okay, so I'm sharing my screen. And also the Oracle. So this is the Oracle part, and let me start the SQL command section area. Am I audible properly? I think so.
Yes, you are audible.
Okay, fine. So last day we did the Cartesian product. Means, okay, let me open the schema. Schema means the table. So these are the tables. We have to find the queries. We have to find the result of the queries. So first day on SQL we did some queries which basically works on a single table. Okay, just like finding some employees whose salary is more than some amount, and the name of the employees who lives in particular city, something like that, name of the department which is being managed by a certain uh, employee SSN number, something like that, which works actually basically which works basically on a single table. So in
Yes,
real life, most often we have queries which needs multiple tables to join or something. You have to consider multiple tables to find a result of a particular query in real life. Okay, so in order to do that, we have two things basically. First is your Cartesian product. Okay, Cartesian product, and the second is your join. So join we will do later, but what Cartesian product is, which we did last class, in our last class, that multiplying these two tables. Okay, now what about multiplying these two tables? Means Cartesian product, it's a
Cartesian.
concept of mathematics, set theory, where
Yes,
it has been told that uh, you have to find the combination of each and every tuple. Means one tuple, tuple means record. One tuple from this
record.
table will be combined with all the tuples of this table. Okay. Then the second tuple of this table will be combined with all the tuples. So in that way, if you have 10 tuples, 10 records here, means 10 records here, and you have 5 records here, 4 records here,
So
10
10 into 5,
10 into
550.
50 altogether 50 records will be there in the Cartesian product result set.
Table.
But
Yes,
in
result.
that result set, we will not have all the combinations right, because you can see
Correct.
from here this combination. Since this combination, this is the record of Sachin Tendulkar who works in department number 4. So if I combine this record with all these records, this is the table which contains the department's details, means the department number along with the department name and the manager's SSN number. So if I combine this record with all these 4 records from the department table, only this first combination, sorry, the first combination means the record from this table and this record will be the true combination. Okay, and all other
Yes,
combination will be erroneous combination. We call them as spurious tuples. Spurious, spurious, spurious tuples. Means, see, Sachin Tendulkar is working in department number 4. So we combine his record with the department 4 records only, not the department 5 records, not the department 8 record, not the department 10 records, right? So that's why I
correct.
am saying the combination of this tuple with this tuple from this table is right combination. All other combinations will be
Spurious.
spurious tuple. We will raise spurious tuples. To get rid of those spurious tuples, we use some conditions. So how to write a Cartesian product? Just a quick look. Say select star from
From
JEMP,
JEP.
comma JDEPT,
Read
where? So if I write up to this, then we will get all the
all
combinations.
the tuples,
All the
combinations.
combinations. So
Attributes complete.
like that. See, select star from JEMP, comma JDEPT. Okay. But first of all, I would like to display the content of select star from JEMP. So, and select star from JDEPT. So let's see the content of JEMP. See, these are the content of JEMP. Okay, whatever there, these contents are there. JEMP, and you have the content of JDEPT. See, now I am running this query. See, this will produce the combination, every combination
Yes,
with JEMP and
correct.
JDEPT. See, you will get these records. So let me increase the row number. So you will get, see, 48 records, because there are 12 records in JEMP.
And 4 records.
See, 12 records in JEMP, and there are 4 records in department table. There are
Department
4
table.
records in department table.
So 48
So
combinations.
total 48 combination. Now in this combination, you can clearly see that Sachin Tendulkar's record is combined with department number 4's record. Okay. And also Sachin Tendulkar's, there must be another Sachin Tendulkar record is combined with department 5 records. After 12 record, it has been combined with department 5.
The fifth record, Department 5.
Again, you will get another combination of Sachin Tendulkar's record
With
with
6,
department 8 record. Okay.
8 and 10 we have.
8 and 10. Okay. So to remove these Fourier tuples, what we have to do, we have to write a condition, specific condition. Now, what the specific condition is? We have to write condition with where clause, where JEMP dot DNO is equal to JDEPT dot D number. Means, see here, this is the DNO, and this record, this field is from JEMP table. See, JDMP table, JEMP table. Inside JEMP table, you have DNO column, and in the JDEPT table, you have D number. So just look at the result here. You can get the idea that whenever DNO and D number become equal, that record I am telling that this is a correct record. See, this is not a correct record because Rahul David work under department 5, but it has
5.
been combined with department 4. So this is a
4.
spurious tuple. Okay,
Yes.
means this record is not right. So to get rid of this record, we use this condition JEMP DNO, means this DNO is basically coming from JEMP table. This D number is coming from JDEPT table. So whenever these two values become equal, we are selecting that only. Okay. So now if I run this command, this query, so you will get only how many records? 12 records.
12
Because
records.
for 12 employees, there will be one, because every employee is work under only single
One.
department, one department.
Okay.
So right, see, there are 12 records, and only see, Rohit Sharma is work under department 4, and it has been combined with department 4, right? Virat Kohli department 4, it has been combined with department 4, like that. Every employee is combined with their respective records, their respective department records. Okay. So this was discussed. This was Cartesian product and was discussed in last class.
Last
We'll
class.
continue from that. Okay.
Kak, mulai kota kursi
Okay.
nih, Bang. Mas.
Ini semua kapu tuh cek.
Okay. Okay. Now today we will do these things. Please tell me whether we have covered this thing or not. Say, I think this we already did,
This
not
we,
like
yes, like and all
is,
we have done.
is null.
Means not on this particular
Ha,
table, on a single table we have done all this.
ha, on a single table.
Means like without the Cartesian product we have done all this.
Between, we did all this thing, na?
Is null, between,
Mm-hmm.
null, not null, all this.
Okay, okay, fine. Now, today we will do union, intersect, and union and intersection. Okay.
Again on set theory, right?
Union and intersection. What is union and what is intersection?
Union means all. Intersection means only the common.
So, how can we implement union and intersection here?
Union means we have to select from both the things. I think again the Cartesian product will apply.
Just a minute. Okay, intersect, then you could have okay. First we do union and intersect, then I am telling you. Now what is union and what is intersect? I'm telling you. Suppose you are having some records, okay. Suppose the name of this field is A, name of this field is B and C and D, and there are
Okay.
another table where the name of this is A, this may be X, this may be Y, okay.
Right. Okay.
So you can perform union between the values of this because the domain of these two is same.
Yes.
Means suppose this is the name of employee and this is the name of, say, manager, okay.
Okay.
So manager is also an employee, okay. So
Yes.
whatever value you will find here and
Similar.
here are similar type of, means you can consider the data type, okay.
Yes.
Then we can say that these two fields are union compatible, and whatever union compatible, that can also be applied for intersection, okay. I'm giving you an example. See,
Okay.
suppose I want to find, see here, look at this table and this table, right?
Yes.
Here I want to find all the cities or all the locations wherever an employee resides and wherever a department is located. I'm telling you again that I want to find the city, all city, okay, wherever employee resides, either employee resides or a department is located. Then with the current knowledge, can you tell me, is it possible to find the result? But we know,
Department it is Yes, department is present means actually. Okay.
Means suppose in our company we have a department at Bengaluru.
Yes.
We have an employee who resides in Mumbai.
Okay.
Okay. So I want to know, suppose these are the two cities only. Our employees are from Mumbai and our
And
department
from
is Bengaluru. Let
okay.
assume. Okay.
Okay.
So then my query is to find the city where employee resides and a department is located.
Department is
So your
also
answer will
located in
be,
the same
okay, we
thing.
have two cities, Mumbai and Bengaluru, right? But with our current knowledge, okay, whatever we learned so far, it is not possible because
Yes.
this city is in JEMP table and this is in another table. Okay, this is also
DEPT table.
you have to manage both the tables, more than one table together to get the result. How can you do that? Manually, how can you do that? Manually, you can do one thing. Say, copy all this thing, put here. After that, you see here is this table contains the location of all department, na? DEPT
Yes.
log. This DLOG
Yes.
field contains the
The
location of all
city of the
department. Then you
department.
take all those things and paste it here.
Now
So
repetition we should
this
eliminate it.
total list gives you the result of my query.
Union.
Okay. You maybe say that Mumbai is repeated
Yes.
multiple times. Okay. You remove those
The duplicate.
duplicates from here. There is no harm removing duplicates like that. Okay. So these are our final record, right?
Final result. Result
Bengaluru.
of.
This is our final record. Okay.
Yes.
Now our aim is to get this result. How can you do that? With our current knowledge, we cannot do that. For that purpose, you need union. So what we did manually just right now, this is basically the union. So we have to select the cities from here. Then we have to select the locations from here. Then we have to
Make the product means the result.
union. We have to union. Okay. Okay. Quickly look here. I am writing the query. So we are first doing the union operation. Let me write the union here first. Union. So my query is
Select the department.
find all the location or city locations where there is a department and an employee uh, employee is from. Okay. Find the all locations where there is a department and an employee is from.
Located in this front.
Okay. First of all, we will do it in array, relational algebra. Okay. So we will use union here. How? First you find something like that. Say you say city EMP city means we are first finding
Employee
the
city.
employee
City.
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 So what will be the relational algebra for getting this column only?
JEMP table.
We have to use the pi operator now because we are fetching vertically.
Part of
We
it
are fetching
vertically.
the attribute. When we are fetching an
Yes.
attribute, we have to use the pi.
Yes. First.
So
5.
pi city, right?
Yes.
Inside you have to write j EMP.
EMP.
So this way you will get this type of result. The column name will be your city, and there will be the value Mumbai, Kolkata,
Bengaluru,
Bengaluru,
Kolkata,
Delhi, something
all
like
the
that.
cities.
Okay. Now
Yes.
after that, what
Okay.
you have to do? You have to find the
Location from the
department.
department data.
So DEPT underscore say city.
Location. LOCAT.
LOC. I am just giving a name. Just previously I gave name to this results as R1, R2. Today I am giving a specific name so that
Okay.
you
We
can
can take
understand
any
better.
name.
You can take any name.
Okay.
So name of variable.
Oh. Okay.
But see here, I am doing something which is new. I will explain it. I am giving a name
Okay.
city within bracket. Okay.
Okay.
Pi. So what I have to write here means now I am
Location.
selecting this
Location.
field, projecting this field. So the name of this field is DLOC.
DLOC.
So I have to write DLOC from which table?
JDPT.
JDPT. Okay. So what we will get from this query? We will get this query result of this query will be means this query will be city. See what I am writing here, city. Okay. Then you have
Okay.
say Mumbai, Delhi, and maybe
Bengaluru.
Bengaluru, something like that. Okay. Now I told you that to perform union, you should have same name column. The column name should be same, na?
Yes. Actually.
Now, if I do not write this, say I am not writing this city. Okay. Just I am writing DPT city equal to means arrow this one. Then this name will not be there. What name
Correct.
will be? This name will be
DLOC will be
DLOC
there.
because we are selecting DLOC, so automatically the result will be DLOC, right?
Okay.
So
To make the
we do
attribute
not
common,
want that. Okay, so to make the name same,
attribute name
we
call
use
same.
this
We.
thing. This is called renaming. We can rename it,
Okay. Okay.
renaming the column,
Okay.
renaming the column. Okay, temporarily we are renaming
Okay.
the column. Is it okay?
Yeah. Fine.
Hmm. Now what we have to do? We have to just perform the union operation between these two. Means these two names. See our
Yes.
result will be then. What will be our result then? So our result
Combination
will be
result.
EMPCT
Union.
union. This is the symbol, union symbol.
Okay. Department.
DPT
City.
city, and that will combine these two results to get this one. This one. Okay.
Yes.
Tell me if it is okay or not. It's very simple. Very simple.
Yeah. Got it.
Just try to understand. If any problem, then just tell me. If anyone have any problem, this is the way how you have to represent the union in relational algebra.
Okay.
Now we will perform the same in our SQL
SQL.
query. Okay. Okay. Just a minute. Okay. So moving here. So what we will do? We will, but see in SQL, see here we separately in relational algebra we have the opportunity to perform the query separately, na?
Yes.
But in SQL we do not have that facility, so we have to write in a single line. So select
in
the city from
from
JEMP,
JEM.
just like that. Just
Hmm.
try to understand. It's very simple. See, if I just run it, so you will get all the cities from the JEMP table.
JEP table. Yes.
Now, if I write the same query for DLOC from JDEPT,
JDPET.
then what will happen? You will get
Only
the
that will be
DLOC
huh.
from JDEPT.
Deal.
Invalid identifier DLOC means we
Select from JDPET. The location only, not this.
JDEPT,
I think data
JDEPT.
is
No,
not
no,
there in that.
no, JDEPT na. The JDEPT
Last time we
underscore
did.
LOC. What is the name of the table? JDEPT underscore LOC na?
And yeah, table name is
Yeah.
different.
So JDEPT underscore LOC, you will find DLOC, right? So you have to write JDEPT underscore LOC. So if you run this, so you will get the DLOC column for the JDEPT table, right?
4 city name. Yes.
So we have to see, here we are getting the city of all employee. Here we are getting the city of all department,
The
right?
department.
So we have
Yes.
to perform the union of these two. Okay.
Yes.
These are the two queries we have written in this way individually. This is the
Separately,
first query, this is the
individually.
second query. We have to union these
Those
two
two
queries.
tables.
So how to do that? Nothing you have to do much. Just you write UNION. Is case
Or directly
insensitive.
writing.
For
Ah,
emphasizing, I am writing it in caps letter.
okay.
Okay. Just perform the union. Just run the query. See, you will get this thing.
Okay.
Okay.
It has been eliminated duplicates already.
Automatically,
Already, automatically.
union operation eliminates the duplicate. I am repeating, automatically, implicit, you will get rid of the duplicate elements. Okay.
Duplicate elements.
Now here you can also see that no renaming is required, no?
Yes.
Because it is also
Renaming.
implemented implicit that it will take only a single one. Okay, I am just writing sorry, I am just writing this query first and then this query, first write the union, then this query, this select operation. So if I run this, what will happen?
First, this table it will come, I think. Then the
Now here the column name becomes DLOC, na?
it will make the
Are you
deal
getting the
common.
difference?
Yes.
Means
Yes. Yes. I
whatever
got it.
is your first query,
First, it is
it will
yeah. That
get the name.
attribute will be
It will
taken.
get the name from there. Okay.
Okay.
So if mistakenly you write this query, both will give you the same result, but the field name will be taken automatically
Different.
by the first one. Okay. So by mistakenly, if you provide this query, so you will be means you will not get marks as far as exam is concerned. Okay.
Correct.
Means it is saying that D log means department log. It does not actually reflect our the result of our query.
Result.
We wanted the city, not the department city. Although the
Correct.
results, the listing of cities are same, but there is a naming mismatch.
Attribute name is
So semantic is not right here. Okay. So to avoid this thing, what we will do, we can do this thing. Okay. We have to write more specifically the city. We have to write the select statement which includes the city word first, or we can do a renaming. Renaming how? DLOC, I have to rename the DLOC, okay, as city. This is the way how we can rename temporarily a column of a table. So run this one, city. Also, if you apply as city here, so running the second query, you will get city. See? Okay. So renaming
Okay,
is
sir.
better for the better semantic. Semantic means the meaning. Okay. So this is the way how you have to perform the select union operation. Okay. Now
Yes,
suppose I am copying this thing and paste, and I put something here, all. Uh, it automatically remove the, okay, it did go. I want to show you something. Select city from JEMP. Okay, just a minute. So if I run it, you will get, see, Bengaluru,
yes.
Bengaluru. Okay,
Ah,
duplicates are there, na?
yes.
Select distinct city will give you only the distinct values. It will remove the duplicates
Duplicate.
from the
But
result.
last query without adding anything it gave, no?
Yeah, it is just a select operation. It is not union. Just follow. Okay.
Correct,
It
correct.
is just
Ah,
it is just select operation. It is not union. Now this operation, this select distinct operation, is automatically done by this union. Okay.
okay.
So whenever you are doing union, it will automatically delete the duplicate part, only give you the distinct values. Okay.
Okay, fine. So
Okay.
both are same.
Both are
Select
same.
also.
No. Distinct, here you do not have to mention the distinct because it is by default in case of union. Okay. But
In
if
case of
you,
union, it is different.
yeah, if you are using only select operation, not union operation, then
Then
to remove the
distinct word should be
duplicates, you have to use the distinct keyword.
there. Okay,
Okay. Okay.
fine.
Now the next thing, suppose I am taking another example of your union. See, I showed you union is performed between different tables. Na? Now, if I extend my query that I want to know all cities where there is an employee resides, where there is a department, as well as where there is a project, then tell me what I have to do. Is it clear, my question? Now, when I get all cities where there is an employee resides and where there is a department, now I want to know all cities where an employee resides, as well as, or sorry, not as well as, where an employee resides, or a department is located, or a project is located. Means I want to know the locations, all the locations with which I have to deal. Maybe it's for project, maybe
Yes.
for department, maybe for the employee. So
Okay.
how can I extend this query? Tell me. Just guess. And okay.
Again,
So
union we can use.
find what is this, is plof na, from J project.
Ah, yes.
Okay. So if I write select PLOC from J project, what will happen? It will give me all the project location, right? Now
Yes.
this query is giving us the cities or location of all departments and employees. Okay, so with that we have to union this thing, as simple as that, right? So what we have to do, we can write again here, see, union, or C as city from J project. Just run it. See, these are the cities
Three
with
tables
which
from three
we
tables.
have to deal with.
Yes.
Means all our employee city, project city, and department cities is been considered into this result. So union can be performed in this way. Okay.
Okay.
Okay. Last one. I want to know. I describe you that union can be performed between multiple tables. Now union can also be performed between a single table. Something like that. Suppose I want to know, say, it's a variety of union Q2.
But the attribute should be same, I think, no? Or is it okay?
See here, select all employees, okay, from, say, Delhi, and with all employees who earn more than 5,000. Okay, this is a query. Now you can tell me, okay, this query can be written like that. This is a single query. Okay, see here,
Okay.
I'm copying this thing here. How to perform, sorry, okay, so how to do that? You can apply a single select statement. Select star
M
from
star from
JEMP where city equal to
equal to
Delhi,
Delhi
and
and
with all employees who,
employee salary is greater
and
than 5.
or
Yes.
salary, na?
Yes. Salary is more than 5,000.
Salary greater than 5,000. Okay, a simple query, single query. If you run this, you will get these are the players or the employees who lives in Delhi or who
Delhi
gets
and
more than 5,000.
salary.
Now
Right.
this query can be written using union. Select star from JEMP where city equal to Delhi, union. Select star from JEMP where salary greater than 5,000.
5,000.
See, I am distributing this single query into two different queries. Na? See, one is this one and another is this one. And then producing the union between these two. So what we will get? See, the same result we are getting.
Same result.
So you have to remember that OR can be replaced by union. This OR can be
Yes. Or
replaced by union. So whatever we performed with OR, that can also be performed with union. So with
union.
our means use wherever which one is suitable, we can perform that thing. Okay. and that is all about union.
Yes.
Okay, so then is it clear, na? Is it clear?
Yeah, it is clear. It is clear.
Okay, fine. Now the intersection. Intersection is same like union, but the only difference is it will give you the means the common part.
Common elements.
Common element means these two tables. If we perform intersection between these two tables, okay. So what we will get? We will get the common. Intersection. I am just taking the same example. Just I have to change the statement. So what statement I can put for this query if I perform it as intersection? Say, find all cities where there is a department as well as an employee reside. Means I have to find find cities where there is a department, and at the same time the city must contain an employee. Means the city must be a home place of an employee, at least one employee. If there is any city in our database, then that city is of my interest. Okay, so this type of query we will perform the intersection. So first we will find all the cities of employee, then we will find all the cities of department, then we will produce the intersection between these two.
These two tables.
Intersection between these two tables. Okay, so it will give the common, means here it is M and B, it is common in both the tables, so M and B will be there. So that will be our intersection. Okay, it's very easy, just like a union. So we'll go quickly with intersection. Let's delete this line. Okay, I will paste all these query in the last part of the paint. Okay. So select. So what we have to do? Select star from JEMP, right? Then intersect. Select star from JDEPT. Run it. See, oh, sorry. Why I am writing star? The city, na?
Yes.
Select city from JEMP and select DLOC as city from JDEPT. Run it. Select city from JDEPT, intersect JDEPT. Again we making the same mistake. JDEPT LOC. See, only these 4 cities are there where a department is located, at the same time an employee resides. So this is the SQL query of this thing. Tell me, is it clear?
Yeah, it's all clear.
Okay, so this is the way how we can perform the
In
intersection
union.
and the union. Okay.
Okay.
Okay. Now there is something called just 1 minute. I am writing
Okay.
this query. Intersect except. I am writing what? Except. Okay. And run this query. Select city from JMP except select log from leave it minus. It will perform minus operation. Means the in set theory we will have operations na, like union, intersection, and what? Minus.
Minus.
You remember the minus from set theory?
Yes, yes, we remember that.
Okay.
Leaving that attribute, it will come.
Yeah, right. So intersection and union, intersect, and minus operation. So here there will be minus. Okay. In Oracle, you will find this command as minus. In some other language, you will find the command as except,
Except.
which I wrote previously. Okay. So minus means whatever the city you will find here. See, look here. From those cities, the city we will find from this table will be deducted. Okay. So these cities are the what? Are the unique cities for employee. Means see, if I select this city, say I am putting a distinct keyword, I have this one. Just remember, see, we have Bengaluru, Delhi, Mumbai. You just remember this thing. So 8: Bengaluru, Delhi, Mumbai, Ranchi, Kolkata, Rajkot, Chennai. Okay.
Yes.
Now I am finding select DLOC from DLOC. So you will find Mumbai, Delhi, Chennai, Kolkata, right? So Mumbai, Delhi, Chennai, Kolkata, these cities will be deducted from this JEMP. You remember this thing: Mumbai, Delhi, Chennai, Kolkata. Okay, just run the employee city first. See, so Mumbai, Delhi, Chennai, and Kolkata will be removed from here. So what will remain? Bengaluru, Ranchi, and Rajkot. Na? Three cities will be there after performing the minus operation. Now we run this query. See, Bengaluru, Rajkot, and Ranchi. So this is the operation of minus. Tell me, is it okay? So in case of minus operation, the statement will be like that: find all cities where an employee reside but no department is located. Means what? Means we have to find the cities only where an employee resides but no department is located. Department will not be there. So what will be the relational algebra? The relational algebra will remain same. Only difference will be the symbol. We have to put a minus operation over here. Okay, so minus is something like that. Now you have to remember that the commutative law works here. Na? A union B will be equal to your B union A. A intersection B must also be equal to B intersection A, but A minus B will not be equal to B minus A. So in these two cases, union and intersection, if you interchange these two things, there will be no harm. If you interchange this part and this part, so there will be no harm. But in case of minus, interchanging these
इन
two,
बिटवीन आपका मीटिंग कैंसिल हो गया तो
sorry,
इन बिटवीन आपने मीटिंग से लेफ्ट हुए थे क्या?
ना तो means
ओके, मेरे को 5 मिनट्स ना लेकर तो नहीं दिख रहा कॉल.
just a minute.
अभी सुनाई दे रहा है. Which is it will be exception and the other it will be like minus command will be there. वही बोल रहे थे आप.
Minus is there to select the records from one table, okay, discarding the others from the other table. Means here, suppose in this query, see here, find all the cities where an employee resides.
या स्क्रीन आपको स्क्रीन शेयर करना पड़ेगा फिर से. स्क्रीन विजिबिलिटी.
I didn't stop sharing the screen. What is happening?
हाँ, अभी स्क्रीन दिख रहा है.
ठीक है. Okay. So find all the cities where an employee resides but no department is located. So if we find all the cities where an employee resides, okay, all the cities, this will continue all the cities where employee resides, and this will contain all the cities where the department is located. So if I minus this table from this one, so what will remain? Only those cities
The same thing.
where there is a employee
resides.
but no department. For that purpose, we use minus operator. Okay.
Okay.
Okay. So the minus operator, I'm just selecting the minus and putting it out here. Now what I am trying to say here, that your union and intersection are commutative, follow the commutative law. Means A union B is equal to B union A intersection B is equal to B intersection A, but minus is not commutative. Okay.
Okay. It could be like a complement.
Minus is not commutative. So A minus B is not equal to B minus A. Okay. So in these two cases, employee and union and intersection, you can interchange these tables. Means EMPCT intersect DEPTCT without you can write the same thing like that, DEPTCT intersect EMPCT. Okay, that will be same. Okay, means EMP underscore CT intersect DPTCT is same as DPTCT intersect EMPCT. Okay.
So commutative.
Because they are commutative. But EMPCT minus DPTCT is not equal to DPTCT minus EMPCT. Okay. So
correct.
What will be the meaning of DPTCT minus EMPCT then?
It could be complement or
What is the meaning of this? This is the meaning of this is that you are trying to find the cities of all departments where no employee resides. Nah.
Yeah.
The meaning of this thing will be you want to find the cities where there is a department but no employee resides. Okay, that's why we are
Doing the
discarding the
minus
cities
operator.
of employee. So this is your intersection, sorry, minus. Okay, so this is all about your set operations using SQL and relational algebra. Set operation means union, intersection,
And
uh,
minus.
and minus. Obviously, Cartesian product and division are also set operation. Okay, Cartesian product we already did last class, in our last
Last class.
class. Division we will do later. Okay, so those are also
Okay.
set operations, but union, intersection and minus we have completed today. Okay, so the next part is your nested query. Nested query. Now, what is a nested query? Nested query means a query can contain another query in it. Okay, a query can contain another query in it. Nesting can go up to any level, means this query contains another query which contains another query which contains another query. In that way it can go up to n level. This is nested query. One select operation can be nested inside another select operation. How? That I am going to show
We
you.
can.
Okay.
Okay.
See here, take an example. Suppose I want to find the employee name, okay, who lives in those cities where there is a department. I am repeating, I want to find those employees. Just let me write the query here. Find the employees, I think it is Q4. Find the employees who lives in those cities where there is a department. Now, what is there inside it? You can do it with the help of Cartesian product too. Okay, but we will do it
Okay.
using the nested query. Okay.
Fine.
Now, see, find the employees who lives in those cities where there is a department. Now, what that means? How to perform the task manually? First of all, you have to find the location of all
Employee
departments.
name.
Okay, now you know that our departments are located in Mumbai, Delhi, and Chennai and Kolkata. Now you have to find who are the employee who lives in Mumbai, Mumbai, Delhi, 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 Mumbai, Delhi, Chennai, Kolkata.
Chennai.
Chennai, there is no one. Oh, one is there, Chennai and Kolkata. Okay, so these employees means Saurabh, Sachin, Virat, Yuvraj, and Ravindra. These employees we have to find, right?
Yes.
So we will perform this task using our nested query. See, how can we do that?
Select.
Say select employee. You have to select the employee. So I am taking F name, comma L name from
Okay.
JEMP where CT in, give a bracket. Inside this bracket you have to put the query, means CT in. I can say you can give cities like that, Mumbai, PAI, Mumbai. Okay, say this query will run fine, na?
Yes.
Since we already did this in.
Correct.
This in we have performed, in, not in, we did. So this query will run fine. So let's run it. See, these employees are located in Mumbai and Kolkata. Now these are specific, na? These are specific cities. We will not write these specific cities. Rather, we will run a query here. Select dlog from dept underscore location table. Okay, just see the output first. I am running this query. Missing right parenthesis. Select dlog from dept.
No, it is not. No.
No, select, I miss a E here. Select. The select spelling was not right.
Correct.
Tabular view does not exist. JDPT. Table name I put wrong table name. See, these are the employees who resides in those cities where the department is located. Now I am explaining it. Just let me explain it a bit. See, look, this is a query and this is another query, right?
Right.
This query is called inner query. Inner query. This query is inner query and this is your outer query.
Outer.
Okay. So the execution goes from inner query to outer query. The inner query will be executed first, then the outer query. Okay.
Yes.
So now tell me, if this query executes separately, then what it will give as a result? Select dlog from dept log table. So what is our dept log table? This is our dept log table. So from this dept log table we will get these values now.
Correct.
So these values will then be replaced here in this section within this bracket, and it will look like what I have shown you earlier.
City like Mumbai.
So it will look like Mumbai, then dot 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 dot. Now you are understanding the thing, I think.
Yes. Yes.
So it will then be converted like this, and after that the outer query will be executed, right?
Yes.
So if the outer query will be executed on this table, on this part, then what will happen I have already shown you, and
Correct.
hence the result. Okay. So this form of query is called your nested query. Okay. Is it okay?
Fine.
Very good. Next we will continue two nested query more. Suppose we want to find suppose we want to find the employee who suppose works in any project, this is works in table, works in any project, see here, employee 1004 works. I have to write it, otherwise you will not remember. See this in or nested query, there is means for advanced query we need nested query. Okay, so
Okay.
Q5b, find names of all employees who works in such project where employee works for say 40 hours or more, maybe something like that. So what is that? Find the name of all employees who works in such projects
Where employee works for 40 hours. So
yes, works for 40 hours. So how can we do that? See here, we have to find the ESSN for those employees from this table who works for more than 40 hours, 40 hours or more. Just
yes,
only one employee I think will be there 45 hours. Okay, maybe
yes, only one.
it may be different in our original table. Let's check, but first let me describe it. So we have to find the ESSN for those employee who works for more than
More
40 or
than 40
45 hours.
hours.
Okay, now as
Yes,
per this record we are getting only
only one
1004
record.
is the employee who works for more than 45 hours, right? Now here we have to move in this table. Now find 1004. Who is 1004? He is Virat Kohli. So we have to get his name. Okay. Now what we will do? How can we do that? We can do that in nested query pattern, that we have to select the name of the employee whose SSN is in all the SSNs which will be fetched from this table, for which hour is more than 40. I am writing it better. So what we will write? Select fname lname from JEMP where SSN in, what it will be? Select
Select
ESSN from
ESSN.
J
J
works
works
in
in underscore in
where
work
hour
hours is greater
greater
than
than
40.
equal to 40,
40.
right? So how it will be performed? First this section will be,
Inner loop will be executed.
this section will be
Inner query will
executed.
be
So we execute it separately. So selecting this part, if we press the run button, so this part will only be executed. See, only 1004 is there. Okay, so in this, so what it will be there? So 1004 will be replaced like that. Okay, and that will be done automatically during the runtime. So no data found means 1004 is not present. This is because we have 1004, 1004, but I think select fname lname from GEMP, select star from JEMP, we should have, this is 100, 1004 is not there, so we have to replace, means the SSN is not there, na, accurate, exact.
Yes.
We did not insert the select star from J, sorry, works in. So here you will find that our SSN becomes 1004. Actually, in JEMP we have 101, 102, 104. That's why it is not matching. So what we have to do, we just update, just like previous day. Update J works in set ESSN is equal to 104, where ESSN is equal to 1004. So it will update the data for 104. So now if you check, so you will get 1004 is there, right? Now we are running this one. See, Virat Kohli is the person. Tell me, is it okay? Okay.
Yes, it's fine.
The next thing, suppose I want to find the employee. Okay, just look here. I want to find the employee who lives in the same city as Virat Kohli. Let me write it, the statement. Find the employee who lives in the same city as Virat Kohli. How can we find that? Looking into the table. So manually, how we have to find out? We have to go to the record of Virat Kohli. Na? Here we are writing Virat. Okay. Maybe we have to check what we have written in our oracle, Virat or Virat. So we have to find the city of Virat Kohli first. Okay. And then we have to match all other records whether their corresponding cities are equal to Virat Kohli's living city, right? And that thing we can perform using nested query. Maybe we can do also this query using join or Cartesian product. See, select fname comma lname from JEMP, where city, now here I am giving equal to. Why I am giving equal to, that you have to tell me. So within bracket I am writing select city from JEMP, where fname is equal to Virat and lname is equal to Kohli. We have to check the name whether Virat's name is given. How the Virat name is given. First, check it. So it is Virat Kohli. I think we have written Virat
Whole.
Kohli. It's okay, na?
Yes.
Okay. Now first run this one. So what it will do? It will find the employee who lives in the same city where Virat Kohli lives.
That it finds even continuously. The last name is also.
Invalid SQL statement. I have made some mistake. Maybe select C.
Select word is.
Select. See, these are the two player or the means the employee who lives in the same city where Virat Kohli lives. The record contains the name of Virat Kohli by himself because see, I told you that this statement will be executed first now. So if I run this statement separately, what it will produce? It will produce Delhi. So now what your query become? Select fname name from JEMP where city equal to Delhi. So if I write that query where city equal to Delhi, then obviously the result will contain the name of Virat Kohli himself. Okay. Okay. Now why I am giving equal to and why I am not using in? You can put always in there. You can also put the in. There will no harm. See here. So in is also give you the result. But here we do not require in. We just give equal to. Why? See, let me copy it fast. Put it there. When your inner query, just listen, when your inner query produced only single value, you can give the guarantee that our inner query produce only single value, then you can use this equal to operator, because then your query will look like where ct equal to. You can always think that we cannot give multiple values in the right hand side of equal to. Now you cannot write ct equal to Delhi comma. This is not the right way of writing the condition. Na? So when your inner query is producing single value, then you can use the equal to operator. But if your inner query is producing multiple value, or there is a chance of producing multiple values in your inner query, okay, then you always put the in operator, because then the condition will become or, all the values will be or together, form one condition. See here, there is a chance, means this will always produce multiple values. Select log from BPT location. So multiple cities will be there. There you cannot put the equal to sign. You have to put the in. Okay.
Okay.
Okay. So this was all your inner queries. Okay. Sorry, nested query. Okay, fine. What we have left with our SQL part? See, we have join, and we have, say, aggregate functions, okay, and some advanced queries. Okay, some advanced queries. Okay, so join obviously we will do next day, but aggregate function I am just I have 6 minutes left, so I am just giving you a hint of aggregate function. Okay,
Fine.
we will do detail in the next class.
Fine.
Have you any other query regarding nested query or union intersection?
I think so. It's all clear.
Okay, fine.
Looks clear to me. Fine.
So Aggregate functions are basically 5 functions are there which are called aggregate functions. The first one is your count. Means if you want to count a number of record, then you have sum. If you want to sum numeric values, okay, then you have max and mean. If you want to find some maximum or minimum among the numeric values or fields, okay, so count, sum, max, mean, and there is called average. Okay, so
It's
these are
similar.
the, sorry,
It is similar to the Excel functions. Is it similar to Excel functions?
not similar to Excel function. Obviously, Excel functions are functions which will be applied on the columns and the values. Okay, here the working obviously the same in the same way, but it is a database concept. Okay, application, the process of application is different, but obviously you can say count. If there is a count or if there is a sum method, then the working of this sum method and the sum method from Excel will obviously be the same. Okay,
Correct.
okay, now where we can apply this thing, suppose we want to find the total salary we have to produce, we have to give to our employee. That means in Excel, if I select this thing and press this one or put a function here, so it will give me this one, na? But how can I do that in our database? Okay, we are not maintaining the Excel. Database is far more better than Excel. Obviously, Excel is also a huge. Okay, many
Okay.
companies totally depends on Excel. Only installing Excel will serve you every purpose. So Excel is huge. I can program on Excel also. Okay, in the back end you can program on VB, .NET, different programming languages. And the macro of Excel is a tremendous thing. See our tax department, India government, okay, income tax and sales tax. Many days or years they are dependent on those Excel macro field. Now
Okay.
for a few years they have introduced the Java version of that tax part, means taxation software are there in Java version, but income tax department have the still they have the option of producing the accounts in Excel software macro. Okay, anyway, so these are the things. Now if you want to count how many employees are there in our company or how many employees are from a particular city, so you will have to use the count operation, right? Now if you want to find how many what is the average salary that I have to give to my employees from Bengaluru, you have to use the average. What is the maximum salary that I have to give to my employee? Okay, and the use is very simple. Just quickly I am just showing you. Next day we will make it, we will elaborate it. Say select, say count, this is a syntax, count star, it will count every employee. Select count star from JEMP, just like that. So it will give you how many employees are there. Okay, count star from JEMP. So count star from JEMP,
Okay.
where city is equal to Delhi. No problem. So from Delhi we have 2, right? If you want to find, select maximum salary from JEMP. See, you will get this is the maximum salary. Okay.
Yes.
If you want to find the total salary given to our employees, so sum.
Oh, correct. Total salary will be some.
So this is the total salary we gave our employees. So in this way we have to use the aggregate functions. But obviously, these aggregate functions are used in huge in SQL. We will show you some more complicated queries using these aggregate functions. Maybe finding the second highest salary, third least lowest salary. Okay,
Okay.
some are other things are there. We can obviously discuss in our later class. Okay, so today I have to leave now,
Okay.
and today we completed to this part. Tell me quickly if you have any doubt.
No, I'm clear with all this. Aggregate functions, nested query, and then we did
Union, intersection, minus,
intersection and minus. Yes, everything is.
lots of things. Okay, I will again send some sample queries. You can always exercise because practicing
Yes,
is all about winning. Okay,
yes, definitely.
okay,
I'll. Okay.
okay. Then thank you. Good night.
So much. Good night.
Okay, just stop the record.